Hello everyone, I'm Dr. Lily Chow from USW Canberra. In this video, I will give you a quick answer of what satellite orbit is. An orbit is the path that an object in space takes around another object due to gravity. This path is curved, regular, and repeating. We call this object in an orbit a satellite. A satellite can be natural like Moon. It can also be artificial. All orbits are elliptical, which means they are ellipses. Satellites that orbit Earth do not always stay in the same distance from Earth. The closest point a satellite comes to Earth is called perigee. The farthest point is the apogee. The time it takes a satellite to make a full orbit is called period. The orbit inclination is the angle between orbital plane and the Earth's equator. We use Keplerian elements to define the shape of an ellipse, how the orbit orients, and define satellite orbit position. These 6 elements are: first, A. A is the semi-major axis, which gives the size of the orbit. Second, the eccentricity, which gives the shape of the orbit. C is the semi-distance between the 2 focal points. E is the C divides A. It tells us how round or flat an orbit is. An ellipse has an eccentricity in the range between 0 to 1, while a circle is the special case, eccentricity equals 0. Third, the inclination angle is the angle between the plane and the central body's equator. It decides the coverage of the orbit. Fourth, the uppercase omega. This is the right ascension of an ascending node, which gives the rotation of the orbit plane from reference axis. Fifth, the lowercase omega. This is the argument of perigee, which is the angle from the ascending node to perigee point, measured along the orbit in the direction of the satellite motion. Sixth, the last one is the mu. Mu is the true anomaly. That is the angle from the perigee to the satellite. It gives the location of the satellite on the orbit. Here, we take 2 Australian-owned satellites, for example. The green path presents the Optus D3 satellite in geostationary orbit. It can be seen that the satellite in GEO circled Earth above the equator from west to east following the Earth's rotation, taking around 24 hours by traveling at exactly the same rate as Earth. The yellow path presents the USW Canberra M2 satellite. M2 is the 3rd mission under the Royal Australian Air Force and the USW Canberra Space Research Agreement. The 2 M2 satellites fly in low Earth orbit. Now, we give the 6 Keplerian elements for the 2 orbits at the UTCG time on 21st February 2021 AM. For example, the semi-major axis of Optus D3 is 42,162 kilometers. The Earth's radius is about 3,678 kilometers. So, it orbits Earth above the equator at altitude of 35,787 kilometers. M2's semi-major axis is 6,931 kilometers, so its altitude is approximately 553 kilometers. Both orbits have eccentricities close to 0. Optus D3 has a very small inclination of 0.14 degrees, while M2 has an inclination of 45 degrees. So, if we know the value of 6 orbital elements, we can specify the location of satellites accurately. There are various types of orbit: GEO, LEO, MEO, sun-synchronized orbit. Upon launch, a satellite is most often placed in one of the several particular orbits around Earth. There are many factors that decide which orbit could be best for a satellite to use, depending on what the satellite is designed to achieve. The simulation is implemented using the system toolkit provided by AGI. Please let me know if you have any feedback. Thanks very much for watching. See you next time.